Many natural phenomena occur at an exponential rate. Examples include discharge of capacitors in electrical circuits, rates of chemical reactions, radioactive decay, and even the rate at which your coffee cools down. We'll use a selection of techniques we have developed throughout the course to examine this sort of behaviour. If we measure the radioactivity in a sample over a period of time, we discover that it gradually reduces as the radioactive component decays. The table shows the amount of radioactivity in a sample at different times. This data has been plotted in the graph. Notice how over time the level of radioactivity dies away towards nothing, but never quite disappears altogether. It has been shown that this graph has a formula R equals R0 times 10 to the power minus kT, where R0 is the starting amount of radioactive material, which in this case is 100, and K is some unknown constant. We would like to determine the constant K, but first we must rearrange the formula. Divide both sides of the equation by R0, which cancels on the right-hand side. Next, take logarithms of both sides. Since the right-hand side was already a power of 10, we are just left with the exponent of the number 10, that is, minus kT. Finally, switch the sign of both sides of the equation. Look carefully at what we have left. This is now the formula for a proportional relationship. It tells us that the left-hand side is proportional to the time t, and k is the proportionality constant. But that means that if we graph the relationship this way, we should get a straight line. Take the original data, but change the second column to minus log of r over r0 and calculate these values. Remember, r0 is 100. Then, for example, when t is 3, r is 25, so we calculate minus log 25 over 100 and get 0.6. Complete the table like this. And now when we draw the graph, it is a straight line passing through the origin. The slope of the graph is the constant k we are seeking. Pick 2 points on the line. The origin can be 1, and I'll choose 5, 1 as the other. So the slope is given by the rise divided by the run, which is 0.2. Therefore, the proportionality constant is 0.2. Notice how so many of the ideas we have introduced, logarithms, algebra, graphing and proportionality, have all come together in this topic. I hope we have given you a glimpse of the power and beauty of mathematics, the language of science.